Hello and welcome. In the next video we'll be learn how to use a pre-trained VGG models, and we'll start by just looking at our dataset that we'll be using for testing. And I have a bunch of interesting looking dogs and cats here. They're actually disguised as something else, and this is just to test our image classifier, our VGG model. So we'll start with just running our predict.py script, which is located in the source directory for this section, and we will go through the output to understand what's going on. So the first thing that we need to do is that we need to type in python 3 predict.py, and then we need to specify the path to the image that we want to classify. So our images are located inside source directory in data directory. So here we have start with dog number 1, and we won't go through all of those images. There are not a lot of them there, but I will do that on the dog number 1 to give you some idea about the output, and then we will go to explain the code step by step of doing the classification. But feel free to actually play around with those other images and see if what kind of results we can actually get, and if we can actually kind of trick our pre-trained models. So in this case we have this dog disguised as, I guess, fireman, and our model classified that image as soft-coated wetland terrier. And I'm not a dog expert, so I'm not sure if this is exactly correct, but it seems that it's very precise. And it also, in this case, got the 32% chance of being that in this class. And as you can see, in this output we've got a bunch of classes and their probabilities. And here we have to keep in mind that the probabilities are presented as floating point numbers, and our last line is actually the most probable class, and we've converted this floating point number into a percentage. And Keras gives us a lot of tools to make this process of using those models really easy, and as you will see in a moment, this is pretty straightforward. But one more thing to keep in mind is that we also have different classes with different probabilities, and that might be useful when you try to figure out a way of actually testing those models, right? Because you can see how close is this model to the actual prediction that you are interested in, and it will of course depends on your specific model, but this will give you some space to actually see how precise, not precise, is the pre-trained model. So feel free to play around with different kind of animals inside data directory and see if we can. And there are some animals that trick the pre-trained model, so I encourage you to find them. And let's now look at our code. So let's open our predict.py script and go through the process of classification step by step. And before we get into that, just please keep in mind to run this script you need to install Pillow, and just by running conda install Pillow. And this is required because Keras is using a PLL library for image processing, and we can't actually use the standard PL library because of some dependency problem with matplotlib's library that we've used in section 1, and Pillow is kind of a newer version of PL library, so it also works very well. So before you run the script, please do that. Please run conda install Pillow to actually make this script work. And the first thing that we are doing here is that we are turning off the debug information from TensorFlow, and as you remember, we are using TensorFlow as a backend library. So we want to do that because we'll get all sorts of informations from TensorFlow. We are not interested in those right now, but once you've deployed those scripts in production, or you're more serious about using those scripts, those methods, feel free to comment that out, right? So leave those information so you know what's going on. And we basically, when we are using pre-trained models from Keras, we are using two sets of imports, or two sets of functions and objects that we are using. So we are using functions to prepare our data from Keras pre-processing image, and then we also use a few functions and also an object, an actual model, a pre-trained models from Keras applications VGG 19. And here we have to keep in mind that we have two options here. We have a VGG 19 and VGG 16, and 19 and 16 means that how many layers do we have in model. The more layers we have, the bigger the model is, so it takes more time to actually load it into memory. So just keep that in mind. If you would like to test VGG 16, just change heavy occurrences of VGG 19 to VGG 16. But by default, we are just using VGG 19 in this particular example. And let's just go through the process of doing the classification using a pre-trained model. So we start with just initializing our model, and this is the import from Keras applications VGG 19, an object called VGG 19. And this is the exact model, or it's very much similar to the model that we've built in section 1, but this one is pre-trained, so it's not only the structure, there's also those weights, this internal state is actually there. So this is a model after the training. Then after that we are loading image from the first argument of our script. As you remember, we've run our script. Our first argument was the name of the image. So we are using load underscore img to load an image into the image variable. And here we have two arguments, first the path to the image and then the size. And remember that each model, it kind of require specific size. In this case, our pre-trained models requires images of size 224 pixels by 224, and we will just resize them straight away so we can then comfortably work with them later on. Then the next step is to actually convert those images into a NumPy array. As we remember from first section, the MNIST dataset was already converted to NumPy arrays, and it could be used straight away. And we also have to shape this data so we can use it with our model again. And here we are just using image reshape to put it into the right. And one thing to keep in mind is here we have our first argument is just the number of images that we want to classify. Here we're just using one because we are interested in classifying just one image, and then the rest of it is the image size that we read straight from the converted image from our NumPy array, and also the number of channels that is used. And this particular model is actually RGB. It has 3 channels. So here we have 2 to 4 as a second argument and the third argument, and this is because we have target size here, so our image has been resized, so we know that it has the dimensions of 2 to 4, and the last argument will be the number of channels, and here we have 3. But we are just reading those informations from our converted image, right? So this makes it really easy. Then the next step is to prepare our image in exactly the same way that those images that our model was used with. So our model was trained with ImageNet images, and they were prepared for this training process in a specific way. And here Keras gives us really simple way of preparing those images. We just need to run preprocess underscore input, and keep in mind that preprocess underscore input is located in Keras application VGG 19 because we are using VGG 19. Keep in mind that in case of VGG 16 you have to import the right function from the right place, so meaning VGG 16 in terms of using the other version of the pre-trained models. So once we've got this image pre-processed, we are ready to make predictions. So we just run in model predict, and as a first argument we just providing this prepared image, and this is basically at this point this is actually a NumPy array prepared in a right way. And after that, once we've got those predictions, we will pretty much get all those information about the name of the classes, and chances are they are encoded in some way, and also those probabilities. And to make things really simple, can use decode underscore predictions to get only the most relevant classes, and this means that we've got only non-zero probabilities, the classes that have non-zero probabilities here. So this is what we've seen in the output, those list of classes and those probabilities, and at this point those are just floating point numbers, as you remember, name of the class and then the probability, and this is what we've got here. And then after that, those probabilities or those classes or labels are actually sorted in a way that the first one, number 0 in a list, is actually the most probable one. So we pick that up, and the last step is to actually just print the name of the most probable class and then convert this floating point number into the percentage. So this is how we generate the output. So as you can see, the process is pretty straightforward, and Keras gives us just ready to use functions so we can prepare our image in a really simple way and then get the output, those probabilities, also in a pretty straightforward way without any hassle. So I hope that this video was useful. In the next video we'll summarize this section and also discuss some of the next steps that you can take to take your image classification skills to the next level. So until then, take care, and I'll see you in the next video.